Hey guys! In this video I want to talk to you about reducing. And this is a concept that's going to come up a lot. You're going to see it all the time. It's this concept of sameness. If you haven't seen it already, we're looking at this idea that two things can be the same even if they seem different. This is the fundamental principle inside of a lot of mathematics. It's where the equal sign comes from, and we're going to apply it a little bit to fractions, right? So, at a most fundamental level, reducing is just a way to make something that's equal, exactly equal, but it looks different. For example, I have two glasses right here, and so, imagine you had like two glasses full of water, and you put some purple food coloring in this left glass, and you put some green food coloring in the right glass. And so they look different, but they're the exact same cup. It's the exact same size of a cup. It's the exact same amount of water in here. They just look a little bit different, but they're the same. They're exactly the same. They're totally identical. That's kind of the idea that we're getting at, right? We really want something that looks a bit different. It doesn't look the same, but it's totally equal, 100% equal. So, what do? We look at some fractions and we say, okay, well, I've seen, what 1/2 looks like. I've seen what 2/4 look like. Well, those actually look pretty much the same, right? Now we can see that, maybe the thing on the right has this horizontal line through it, dividing it into 4 pieces instead of just 2 pieces. But we know, based on how much is shaded, that they are actually equal. They're actually the same. And so, over time we're going to work on this skill, but if it said, reduce 2/4, we would know, oh, well, 2/4 is equal to 1/2. We know that. And so we would say, at the bottom down here, 2/4 equals 1/2. And that's good. So this is kind of the idea, right? If we move on, we've got so many things that are equal to 1/2, lots of things that also are not equal to 1/2. But just all this stuff, if we were to take 3/6 over here, 3 out of 6. This looks quite a bit different, actually, from this first one. It looks very different from 1/2, but it actually is the same because we know the same amount is shaded in. So again, here we could say, okay, well, 3/6, I know that equals 1/2. So, answer, 1/2, 3/6 equals 1/2. There we go. And we got that whole thing, right? And then if you wanted to do this last one over here, 4 out of 8 is also the same as 1/2. That's how you could make 1/2. It's another way of having that same exact amount. If you had 4 out of 8 equal pieces, that would be the same as having 1 out of 2 equal pieces, right? This is the same. So, if we have 4/8, that's going to reduce to 1/2, and it also reduces technically to like 2/4. It's also actually equal to 3/6. It's equal to all these things because they're all equal to each other. And you can see here they're clearly all 4 the same amount, the exact same value, even though they look different. Even though 4/8 looks different from 1/2, they're actually the same. So, 4/8 technically equals 2/4, which also equals 1/2, right? So we've got kind of all this stuff going on over there. So, this is the basic principle of reducing. This is what we're going to do. We're going to make something that is equal, but it looks a bit different. And let's practice.